of it. So this is SIG Scalability meeting, 26 May 2020. And today we have one topic on our agenda, which is fake kubelet manager. So
yeah,
do you want to start?
Yeah, sure. Could you make me co-host so I can share my screen?
Yeah, sure. Give me a second. I just need to figure out how to do it.
I think it should be in the participant panel and right-click me.
Yeah.
Yeah, sure. Okay. Stop. Can you see my screen? Can you see my screen?
I'm sorry. Oh yeah, I can.
Sorry, yes, I can see
okay.
that. I was muted.
Okay, cool. So today I'm gonna to present a tool that can enable simulating fake cluster with a lot of fake cube nodes. And we know that there is already a tool called QMark or called HoloNode in the upstream. So basically the traditional way is that if I have a local cluster, no matter it's spinning up from source code or from Coin or from whatever. So basically there is just a bare control plane, and then I can launch as many as the fake kubelet or hollow nodes as I want. So I'm just gonna to demo how the hollow node works today. Give it a few seconds for it to come up. Yeah, so here you can see that it's a local cluster spinning up from the source code. I'm using the 123. And you can see that because I use the command no kubelet, as in the beginning is that, yes, that mod is no kubelet. So basically it's a bare control plane. And then the traditional way to run QMark or run kube hollow node is that it's like this. It's you have a binary or have an image, and you and then you use the binary into an image or run as a standalone binary and run some configuration here. So basically here to simulate a 20 node cluster. So basically I'm running 20 hollow node binaries here. Yeah, this is based on the 123 release. And after this, you can see that there's 20 nodes, right? Yeah, this is, we all know that it works. And I think, although I haven't been closely watched the progress of the QMark for a while, but I think maybe it's still the latest status of how QMark running underneath using the hollow node binary, right? And with this, definitely it works in most of cases, but in terms of scalability, I mean, how you scale from a 20 nodes to a 2000 nodes. So basically the usage will just increase in a linear manner. You can see that on my local desktop, most of them takes 55 megabytes, so 20 will equals 1 gigabyte. So if that means it's basically impossible to run 2000 nodes or 5000 nodes, fake nodes on my local cluster. So, and also definitely I can try to schedule a pod here. And you can see that the case is that hollow node, I think it's basically was developed from the skeleton of the kubelet code base. So it remove any unnecessary things or mark some interface. So you can see that there is something not totally stripped off. because it's a virtual thing, so we don't quite need something like DNS or stuff. So I think that's the thing that it takes extra memory that we may not need. So, but functionally it works, right? You can see, yeah, the pass part was scheduled to the 20 nodes. Okay, so next I'm gonna to show another way to simulate this achieve the same goal, but with less memory and start this. I'm not sure, just a local hackup script sometimes doesn't get things cleaned up thoroughly. So next, I'm going to use the same command to start it up, and I'm going to introduce a project called Fake Kubelet. So it works slightly different with the Hollow node. So basically, it's more a controller, a manager that running there, and watch on any node event pushed to APS server, and then take over the node events. And also, it will take over the partial responsibility of kubelet, like to transfer the state of a pending pod with the spec no name to running state. So basically, it just does the minimal things to maintain the state of the pod as well as the heartbeat of the node. So it just does the minimal thing. It doesn't do any like image or any node particular things. So it's a basic controller. And okay, so here you can see that it has a local running control plane. You can see there's no node here. Next, I'm gonna to start the fake kubelet. So the name is a little confusing. Maybe we can rename it to like fake kubelet manager or take over, something like that. So next, I'm gonna to spin up 1,000 fake nodes here and using this tool. So you can hear the full command. So basically, it's just a one binary. And the parameter replicas equals 1,000 is to, it's like just you spend 1,000 node requests to the API server, nothing else. It doesn't really run some internal Go routines or whatever there. It's just issue 1,000 requests there. And you can see it here, we have 1,000 nodes running here. And then the memory usage, because there's just one binary, so it's just a take you 25 megabytes. And if I deploy that, yeah, it will be scheduled to a random node. And if you want to introduce some new node to the cluster, you can say, like, say 1001. Maybe there's some capacity I should dump to. Or give me 1 second. I don't need the init. So I will remove unneeded stuff. 1001. Source version, I don't need it. Spec, I don't need it. Address, let me just keep it. Condition, I don't need condition. Let me just keep it. So let's say we can just make whatever. Change the default spec and apply it. So basically, it's just an API call, right? And it will be taken over by the fake Kubernetes manager controller. Yeah, you can see the 1001 node can be take over. So you can dynamically build the node spec, fake node spec, and spin up a cluster easily. So that is why I want to present this to SIG Scalability, because this tool can potentially enable you to run maybe KubeMock in your local laptop with limited memory. And also you can basically right now, my scenario is to try out the scheduling behavior by given different scheduling strategies, like tuning the weight, like something else. But it can be extended to some control plane, performance, latency, scalability test with the minimal memory footprint. So that is basically, I want to bring it up to scalability. And also I present it to SIG scheduling as well, but I think it most related with SIG scalability. Maybe I can do some POC to see whether it can replace Hollow Node to fit into the scenario of the KubeMock. Yeah, that is basically the demo.
Cool. Yeah, that's that looks great. I think the question is like, how far we are from like the load that is generated by like this fake kubelet, comparing to like real cluster, because even with KubeMark, we are seeing pretty significant difference in terms of like load that the hollow kubelet is generating on the control plane. And I think we are like the main focus is or the main focus was always really around like API servers. So like the more we fake, the less load or lower load or like smaller objects or whatever and so on we are getting on the API server. So to be honest, like the biggest benefit I see exactly in the use cases that you mentioned, like for example scheduler, where we if we want to figure out like how fast the scheduler is or how big improvement like the certain change in the algorithms its scheduler it's bringing up,
behavior,
or
yeah,
how fast maybe, I don't know, controller manager is, or like replica set controller or whatever, like if this fancy new improvement there, I can see a huge advantage of that for like those kind of use cases. I don't think we will be able to replace our existing tests where like the biggest problems are usually at the API server level. So I think I would treat I'm very supportive like to see that building some tooling about that, but I think it's more additional thing than a replacement of anything that we have currently.
Yeah, exactly. So because I haven't followed up with the KubeMock for a while, like you said, I know there is some particular thing that KubeMock is simulating, but this tool is not. So yeah, I just proposing that, not necessary to replace those whatever. So in my current scenarios, so this gives the user a very convenient and performant way to craft a local cluster with 2000 fake node or whatever. Then based on that, we can build like kube scheduler simulator or container manager performance tester atop this fake cluster. So that is the most benefit of that. So right now I'm building some like the Cube scheduler simulator to test some configuration. That is why I think this tool is pretty useful and I want to present. Yeah. So
sure, I absolutely agree. And as I mentioned, I think like scheduler is not the only place. I think like stimulate or evaluating certain changes of like pretty much any master controller, it would be useful. Like, I don't know, daemon set or whatever, job controller or whatever. I think it would be fairly useful. So it's not just scheduler. I think it's from that perspective, I think it would be fairly useful for multiple people. I think as I mentioned, I think it's not a replacement, but I think it's a useful thing to be able to run it, to test certain things at scale on your local laptop.
Yeah, thank you.
So yeah, I think we've been chatting about something like that like years ago, and like it never materialized. So I'm really happy to see that.
Yeah, so I'm pretty glad that you are supportive on this. So next thing is that I want to draw more attention from the community that we have this kind of tool and draw more contributor to co-contribute to the project. And due to some policy in some companies, if this project is a personal project, people may not be legally contribute to that. So next thing I want to do is to promote it as a Kubernetes as a SIG repo sub-project, so more people can get involved. So I'm not sure what's your opinion on this.
Sure, yeah, that I think I absolutely agree that it's much easier to use something that is like officially a SIG owned project than something that is anyone's personal pet project, right? So I think I'm definitely supportive for like saying that it's a useful thing. So if you need any help with convincing anyone that it's actually useful, I'm happy to help with that.
Yeah, I also talked to Paris and some other guys. So basically, I can definitely promote it to sponsored by SIG scheduling, but according to the essence of this project, it's more in scopes related with SIG scalability. So I'd like to propose it to be sponsored by SIG scheduling if you and Marcel don't object.
I think the question is like about maintainability. I think
I will take most of the maintainability responsibilities.
Yeah, I'm definitely not against. I think we will not have capacity to really help visibly with anything here, but I think that makes.
Yeah, I would say that definitely, like if we find some like really cool scenarios for example, for scheduler, then I would be totally fine with, adding to our set of benchmarks, like new benchmark using this fake kubelet. I think it would totally make sense, because right now I think we use kubemark, but kubemark in this case, for example, for scheduler or any other master controller, I think it's not necessary, and we could probably use fake kubelet here.
Yeah, agree. Yeah. So
yeah, I mean, if you are interested in, like then later using it in actual tests that we run, then definitely we can help you with setting it up.
Yeah, I think the first thing, that's the next step. After we get it promoted to a SIG to the Kubernetes SIG project, and if you don't object, I think I can make it co-sponsored by V2 SIG. How do you think? So that I will take most of the review, releasing the regular development responsibilities. And basically, if you have bandwidth, you can jump into a review, right? But I will take the primary ownership and the review responsibility for this. I can claim this co-sponsored by SIG scheduling and SIG scalability. How do you think? Okay, perfect.
Yeah, I think that makes sense.
Yeah, sounds great. Yeah, I think that's pretty much all I want to present. And also, I just demoed that how it works with a local image, but it has the potential to be used by a regular user, which doesn't necessarily need to touch the code base, right? So basically, another scenario is that I just create a node cluster and just deploy it as a pod, and then it will take over all the later nodes created onto the cluster. So basically, it's more, then it gets more usage to regular users who can, okay, I'm just not an experienced Kubernetes programmer. I just a regular user. I can use this tool to spin up a local cluster. I can do some like deployment test, whatever, and like replay my production workload to my local environment, and then test out how to compose or bin pack or whatever kind of scenarios before it rolling out to the production cluster or turn into some Kubernetes expert for help. So I can play with that locally. So. All right, thank you so much. And thank you for your time. That's pretty much for me for today's demo. I will follow up with the project creation.
Okay, great. Thank you very much for presenting that.
Sure thing. Yeah.
Thank you.
Yeah, thank you.
So I'm wondering if we have anything else on the agenda. I don't think so. So thank you for meeting, and thank you for presentation. And see you in 6.
Yeah, thank you. Bye. Have a good day.